Today we're going to talk about square roots and what square roots mean and how to find square roots. So let's start with some terminology. This is called a radical. This is the radical symbol. Whatever we put underneath it is called the radicand. Now, in this case, since there's no number here, or if that number was a 2, we're looking for the square root. And that's what we're going to be sticking with for the most part. The square root of a number is some number so that when we square it or raise it to the second power, we get 36. So square root of 36 equals some number so that when I square it, I get 36. Now, what number would I square to get 36? 6. So the square root of 36 is 6. Now, we're only going to be taking the square roots of positive numbers, but those square roots themselves can be positive or negative. So, for instance, radical 49 is just a number so that when we multiply it by itself, we get 49, which is 7. The opposite of radical 4 is a number so that when I multiply it by itself, I get 4, which is 2. The opposite of that is negative 2. Now, it's important to understand that not every number has a perfect square root. 4 and 49 have whole numbers as their square roots. So did 36. So will say 100 or 25 or 64. These are all perfect squares because their square root is a whole number. But sometimes we can't find a whole number that fits. In that case, we want to approximate it. So in example 2 in your book, we have the top of a folding table, which is a square, whose area is 945 square inches. And we want to find the side lengths. Now let's label the side lengths S. And we know that when we square S, we get the area of the square, which is 945. And we want to approximate that to the nearest inch. So let's think about this. What I can do is I can look for a number that 945 must be close to. Now 28 squared, if we do that on our calculator, is 784. 29 squared is 841. So I can get closer, and I know that the square root of 944 is going to have to be bigger than 29. 30 squared is 900, so we're going to need it a little bit bigger. 31 squared is 961. So that means that the square root of 945 has to be somewhere between 30 and 31. Let's look at it this way. 900 is less than 945. 945 is less than 961. So the square roots of each of those numbers have to follow the same order because they're bigger than 1. And the square root of 900 is 30. And the square root of 961 is 31. That's what we're doing up here. And so the square root of 945 must be somewhere in between 30 and 31. So which one is it closer to? Well, 945, is it closer to 961 or 900? 961, which means that the square root of 945 needs to be closer to 31. So 31 is the nearest whole inch that we can come up with that side. Now, if we're taking a square root of a number that's not a perfect square, we get what's called an irrational number. Now, the opposite of irrational is rational. Those are the numbers that we're used to. Those are the numbers that break down a little further into integers and whole numbers. Irrationals don't do that. They don't break down any further. Irrational numbers look like the square roots of numbers that aren't perfect squares. For instance, square root of 2. There's no number so that when we square it, we get 2. So the square root of 2 is irrational. Or the opposite of the square root of 41. 41 doesn't have an even square root, so we know that that has to be irrational. So we can use this to classify some numbers. Radical 24. Is that a perfect square? No. So that's irrational. But it's important to note that just because it's irrational doesn't mean it's not a real number. It's still a real number. How about the square root of 100? That's equal to 10. And we know that that's a whole number. Since it's a whole number, it's an integer. Since it's an integer, it's rational. And since it's rational, it's real. How about negative radical 81? What number times itself equals 81? 9. So we're looking at the opposite of 9. Now since it's negative, it's not a whole number, but it is an integer, which means it's rational. And a rational number is also a real number. So now we're going to use what we know about radicals to put. Let's start with a list of numbers. We want to place them, put them in order from least to greatest. So let's bring up a number line. Now, on this number line, we'll put 0 somewhere around the middle. We'll let every other one be one whole. Now, 4/3, that's 1 1/3. So that's going to go somewhere around here. What else do we know is easy numbers? Negative 2.5, that's going to go halfway between negative 2 and negative 3. Radical 9, what's that equal to? 3. So we can put that there. So now we got to figure out where these two go. Let's think about this. Radical 5 is somewhere between two numbers. Well, we know that 5 is between two perfect squares, 4 and 9. So radical 5 has to be between their square roots, 2 and 3, which means that negative radical 5 is between negative 2 and negative 3. Now, is 5 closer to 4 or closer to 9? 4, which means the radical 5 is closer to 2, so negative radical 5 is closer to negative 2. How about radical 13? What two perfect squares is that between? 13 is between 9 and 16, which means the radical 13 has to be between the square roots, 3 and 4. That means radical 13 is somewhere over here. So now we have our numbers from least to greatest. Negative 2.5, negative radical 5, 4/3, radical 9, and radical 13. I'm going to give you a list of numbers, and I want you to try that yourself. Let's start with negative 9 over 2, followed by 5.2, 0, radical 7, 4.1, and finally negative radical 20. Take a few minutes and put those on your number line to figure out the order from least to greatest. Okay, let's put 0 right in the middle, and that gives us our first point. Now, negative 9 over 2, that's equal to negative 4.5. So that's going to be halfway between negative 1, or negative 4 and negative 5. 5.2, it's got to be just past 5. There's 2 down. 3 down, actually, because we got 0. 4.1 is just past 4. So let's look at our other two numbers here. Radical 7. Now 7 is between what two perfect squares? Right, 4 and 9. So radical 7 has to be between their square roots, 2 and 3. And since 7 is closer to 9, radical 7 needs to be closer to 3 than 2. So put that right about there. Then we have the opposite of radical 20. So let's consider radical 20. 20 is between what two perfect squares? 16 and 25. That means it's the square root of 20 is between 4 and 5. And since 20 is closer to 16, because it's only 4 units away, than it is to 25, then radical 20 is closer to 4, which means negative radical 20 is closer to negative 4 than negative 5, which puts it just inside the negative 9.2. So then we can write our order, negative 9 over 2, negative radical 20, 0, radical 7, 4.1, and 5.2. There's our order. Okay, so let's use these and go back to our conditional statements that we learned about a few lessons ago. Remember that a conditional statement is a statement that can be written in if-then form. So our first step is to rewrite a statement in if-then form, then we're going to decide if it's true or false. So the given statement is, no fractions are irrational numbers. So let's think about it. Fractions fit into a group of numbers. So if a number is a fraction, then it is an irrational number. Or it is not an irrational number. Because it says no fractions are irrational numbers. Now, is this true or false? Now, as we learned from our definition of rational numbers, a rational number is any number that can be written as a fraction of two integers. And an irrational number is the exact opposite of a rational number. So since a fraction is a rational number, it can't be an irrational number. So that statement is true. The next statement is, all real numbers are rational numbers. So if a number is real, then it is rational. Now remember what I said earlier about the real numbers being split into two separate parts, rational and irrational. Both of them are real numbers. So rationals are real numbers and irrationals are real numbers. So all we have to do is come up with an irrational number that is a real number. So if you can think of a number that is not a perfect square and take its square root, that's irrational. Like 77. Radical 77, or the square root of 77, is irrational, but it's also a real number. So it's a false statement, and that is our counterexample. If you have any questions, feel free to ask. You can go back and watch the video again. Or if you're all set, you can move on to your homework.